Hi everyone, this is AI Travel Companion Group and today we are going to present our Lab 4 assignment. I'll start with the stock price prediction part and then my teammates will walk you through the advanced prediction algorithms and the mock trading environment we built. So first, let me talk about the data preparation. We collected our data from the Yahoo Finance API using the stock price of Apple, Google, and Microsoft from 2020 to 2025. So that's a 5-year data set. And then we split it into three parts: the training, validation, and testing. And specifically, the training set covers 2020 to 2024, the validation set covers 2024 to 2025, and finally, the test that spans from March to September to 2025. The training and validation sets were used for fitting and tuning, and only the test period were used for trading. Here you can see how the stock price looks over time. For example, we can have a look at the green line. The Microsoft shows a lot of variation during this period, and in comparison, Google and Microsoft were steady over this period. Now let's move on to the algorithm and metrics. So we experimented with three models: the moving average, autoregression, and ARIMA. And to evaluate the model's performance, we used MAE and RMSE. Um, the detailed functions were defined in this arima.py file. So here we define several functions. For example, we clean the price series and we align by the index and return, and we define the walk forward ARIMA model, and also we define a grid search approach on the validation set to select the best parameters. So to run this py file, we first load the data and split it into train, validation, and test set. And we shared parameters like the window, the update mode, and the trend, and so on. And then we applied the hyperparameter on the validation set to select the best parameters. And then we train the model on the training set and evaluate the model on the validation set, and finally make the prediction on the test set. And then we calculate the metrics for each split and save the results to a CSV file. And we also set up a trading signal that compares the ARIMA prediction at time t with the actual close price at t-1. And we saved all the results to the prices prediction ARIMA file. Now let's look at the results. So for Apple, we use an ARIMA 011 model. It shows an absolute error, mean absolute error on the validation set of 2.4. And here you can see the comparison between the ground truths and the predictions. They almost overlap, which shows the model performs quite well. And we apply the same process to Google and Microsoft. And the predicted results are shown here. So that's how we carried out our stock price prediction.
I'm going to introduce another time series model that we used to forecast the stock price, which is the LSTM model. Here are the functions for setting up and defining the LSTM model. We use this LSTM model to do a real-time rolling one-day forecast. We will use data in a certain time period to forecast one day in the test set, and we'll include the actual data of the current date in the test set and update the model when we forecast the next day in the test set, so that we can simulate the real-time forecast scenario. After defining the model, we first read the stock features dataset. Different from other models, in the LSTM model, we not only improve the close price but also other features such as open price, highest price, lowest price, and its volume. This is the multivariate characteristic of the neural network-based time series model, which can consider information from more aspects other than the forecast price. However, this is also risky of generating noise in the model. To avoid this, we implement LSTM models on both univariate data, which only contains the cross price, and the multivariate data separately. The performance matrix, which are MAE and the RMSE, shows the multivariate models will not create noise and has better performance. Therefore, all models displayed in this script will be multivariate models. After reading the dataset, we will create a dataset for our first stock, the Apple company. Then we implement the LSTM model on it. We implement a grid search of the hyperparameters look back from 40 days to 180 days, which is the forecast time periods in the model. We also train other hyperparameters such as the number of hidden neurons, the number of layers, the dropout rates, running rate, approach, and the final early stop fractions. The best model is selected based on the performance of RMSE and MAE on the validation set. The combination of hyperparameters displayed in this script is the best combination of that we selected. After determining the best model, we retrain the model on the dataset combining chain and the validation set and use it to forecast the test set. Here is the performance for Apple stock. We can see that it has the MAE of 3.36 and RMSE of 4.97. Then we repeat this process on our second stock, the Google company, and it results in the MAE of 3.44 and RMSE of 4.54. Finally, we implement these pipelines on our last stock, the Microsoft company, and it results in the MAE of 6.04 and the RMSE of 8.32. Or this LSTM model results in a moderate performance compared with ARIMA and the moving average models. It is not surprising that it does not outperform the simple time series model ARIMA, because our training data set for each stock is 878, which is relatively small for these complex neural network models to implement and forecast, as it always leads to overfitting. In order to improve our models, we select the top two models based on the MAE and RMSE and develop a hybrid model to combine their forecast values to obtain the new forecast value. We want to use the weighted average method to combine their forecast values, so we use the linear regression to determine the weights of each model. We implement the linear regression on the forecast values of the validation set and use the true validation price as the target and use this trend linear regression to forecast the test set and obtain the final forecast values of the test set. Here is the functions to read the forecast value from ARIMA or moving average models, and this is the function to run linear regression on the combined forecast value dataset. And here we are implementing these two functions. And this is the performance of the hybrid ARIMA LSTM model on the Apple stock, which obtained the MAE of 2.4223 and the RMSE of 3.3131. For Google stock, the hybrid ARIMA LSTM results in the MAE of 2.842 and RMSE of 4.0203. For Microsoft Store, the top two models are ARIMA and the moving average. So we implement the hybrid model of ARIMA moving average, and that results in the MAE of 5.6219 and the RMSE of 7.6289. Finally, only the hybrid model of ARIMA and LSTM on the Apple stock outperforms other three singular models. So the final model for forecasting Apple stock is hybrid model hybrid model ARIMA LSTM, and for the forecasting Google and Microsoft stock are ARIMA models only. And then we combine this forecast with the combine the hybrid forecast with the ARIMA forecast and output the final results to the CSV code price prediction.
Hello, this video gives an overview of our mock trading simulation that we implemented for Lab4 of DSCI560. We'll have a separate portion in this video where it goes more in depth into the algorithm itself and the output that the algorithm gives. This portion of the video is just focused on the trading simulation part. So our trading simulation, it takes in as an input the output of our algorithm, which again is going to be covered more in detail in a separate part. But at a high level, the output itself of the algorithm is a CSV file. It could also be an Excel file, but in our case, it's a CSV file that has as columns the ticker, so that's the company being traded, the date. In our case, we're doing daily intervals, so this is going to be a row per each day, per each company. And then we have the closing price, and then we have the predicted price for our algorithm for that day. And then we have the signal. So in our case, our signal is just going to be increase or decrease based on what the predicted price is. So if the predicted price for a given day is bigger than the closing price for the previous day, the signal is going to be increased because it's basically signaling that you should increase or you should buy on the previous day because the price of the stock is going to increase. And then conversely, if the signal is decreased. So our code mainly happens in this run simulation function. It basically reads in the CSV file that we give it. In our case, it's this prices predictions CSV file. And it filters on specifically the past 6 months because the algorithm that we use, we define 3 different time periods for the training period, the validation period, and the test period. In our case, in total, we're looking at the last 5 years of data. And for the test period, which is what the simulation is basically executing, we're doing that based on the 6 months. So evidently, most of the time period is consumed by the training and validation, so the predictions are more accurate. So that's this filtering happening here. And then at a high level, what this is doing is it's basically grouping everything by each day. So that's this outer loop here. And then internally for each day, it's iterating through all the companies for that day. And then it's grouping basically the stocks, so the companies that it needs to buy and the ones that it needs to sell based on what the signal is. The signal for the next day, that is. That's why we have this here, because the signal for the next day is indicating what we need to do basically in the current day. And so that's what this is doing, essentially, just grouping the stocks that need to be bought and the ones that need to be sold. And then it's executing the buys and the sells. For the buys, it's trying to distribute whatever cash is available amongst however many stocks needs to be bought. And then for each stock, with that portion of the money that it was allocated, it tries to buy as many shares as it can with that remaining cash or that remaining portion. And then for the sells, it's just selling all the shares for that stock if it held any shares for that stock, because it could be the case that it wasn't even holding any shares. So if there were shares to be sold, then it just executes the sell. And then finally, as all of this is happening, it's also keeping the database up to date. So it's keeping up to date the shares for each stock in that portfolio based on the buys and sells that were just executed. And then it's also keeping up to date the current value of the portfolio itself. So that's this part over here. And then finally, we're just calculating some metrics based on the simulation execution. So we're calculating the final portfolio value. So however many, or the amount of cash that it was left with at the end. Then we also have the separate metric, which is just any leftover cash that wasn't used for any trading. Typically, this is just a small amount that wasn't able to be used for any trades at the end. Then we have the annualized return, which in our case is the 6 months that we ran this on, but extrapolated over to 12 months since it's annualized. So ideally the test would be based on the past 12 months, so the annualized return is a bit more accurate, but the extrapolation still gives an idea of the metric. And then we have the Sharpe ratio as well, which is calculated with the traditional Sharpe ratio formula. So in order to run this, you can see this here, but I can run it again. Basically, it just takes in two parameters. It takes in the portfolio name. So it assumes that you already have a portfolio and you already have some stocks in it. In my case, I already created a portfolio and already added stocks for, in our case, Google, Microsoft, and Apple. And the way that I added that portfolio is using the same script that we submitted for Lab4. So this stock portfolio user interface. I just ran that and I just created a portfolio and added some stocks to it. So in my case, that's called Lab4, the portfolio. And then the second parameter is whatever initial investment you want to give the portfolio in order to run the simulation. So I'm just executing the trading simulation on Lab4, and then I'm giving it an initial investment of 100K. And these are the returns at the end. You can see they look pretty good. We got an increase from 100K to about 132K. And then, as mentioned, the analyzed return metric might be slightly misleading because it's extrapolated to cover the 12 months based on what the return was in this 6 months of trading. So, but it still gives a general idea. But in this 6 months of trading, we basically got around a 30% increase. And that's it. Thank you.